Okay, so we're going to do a little bit more with the rational and radicals. So we're going to look at evaluating.
So it'll be E.
Oh yeah, evaluating. Right? Is it? It is because you guys.
You already did D.
Yep. Because you guys had an extra number. Okay. E. Evaluating. Okay, so we're going to start with a little bit of the notation. So this could be find tangent slope. Okay. Remember that tangent slope is a way of asking for the derivative number. Okay. So it could look like this, f prime of number, right? All of these things are asking for the same thing, okay? It could look like this, dy dx, okay? Dy dx is the derivative in the other format, okay? Bar x equals number. All of these things are referencing the specific number you're supposed to plug in, okay? So remember, tangent slope is like the words way of asking you to plug into the derivative. So we're going to look at evaluating today, okay? So here is our first example, okay? Find f prime of 8. Okay? That's the question. F of x is 1 over cube root of x squared. Now, it's not a polynomial. So you've got some work to do before you get to the actual plugging in part. So the first thing I'm going to do is I'm going to rewrite it into power format. So notice that the x is in the denominator. So that 2 has to change. And that 3 has to move. Okay, if you have to change locations, bottom to top or top to bottom, the exponent becomes negative. So the first thing I did is I dealt with the power part. The next thing I'm going to do is I'm going to move the root. That's power format. That's what you have to have before you do the derivative. Okay, so the second step is going to be to actually find the derivative. Okay, so the derivative is where you multiply the power and then subtract 1. So minus 2/3 x subtract 1. So I'll just do a little bit of subtracting over here. Okay, so minus 5/3. So minus 5/3. And then put it back. Okay, so I'm going to circle the things that have to move. Okay, so I've got the negative exponent, so that has to change. And I have a 3, so that's the root. Notice the fraction here. I'm just going to leave the fraction. Now, I extended the fraction bar because I got to put the x in the denominator. So I made room in the denominator. So x to the 5th power. That's the first thing I did. I moved it to the denominator so that the sign would change, and now I have a positive exponent. And then the 3 is a cube root. Okay. F prime of 8. Now you plug in. Okay, now we plug in. So negative 2 over 3, okay, cube root of 8 to the 5th. Sorry, that's a little small. I don't really want to do 8 to the 5th. So I'm going to switch the root and the power around a little bit. And I'm going to do cube root of 8. And then I'm going to do the 5th power. Because power and roots are kind of the same thing. They're both exponents. So you can do the power or the root in whichever order seems a little easier. Okay? Yes, you can still use a calculator. That's fine. Okay? But I'm going to show you how to do it without. Okay, so I'm going to do the cube root of 8. That's 2. Okay, the cube root of 8 is 2. And then I'm going to do 2 to the 5th, which is 32. And then we get negative 2 over 3 times 32 is 96. Okay. And that reduces to negative 1 over 48. Yes, you can use your calculator to help evaluate any of these things. Just, I would like the answer as a fraction, not a decimal. Okay. Okay. Here we go. Ready? We're going to do another plugging in, right? Look at the colors on purpose. First, I put it in power format. Then I did the derivative. Then I plugged it in. Question 2. Question 2. Find dy dx when x equals 6. Okay, so that's different notation. That means the derivative, right? dy dx is the slope at 6. Okay, so here is your y equals square root of x plus 2 square root x cubed over 3. Okay, first thing you have to do, power format. So I'm going to look, okay, I've got this root and this power. Now this is a power 1 and it's positive, so that doesn't have to change. So it's going to become x to the 1 over 2, right? That's a square root. Notice I didn't actually circle a 2. You just have to know that's a 2. Okay, this one, right? Notice how the 3 is already positive and it's in the numerator. It's not moving. Okay, notice that the 2/3, okay, 2 over 3, the coefficients are not moving. It is just the x. Okay, x to the 3 over 2. All right, 2 steps. Find the derivative, so that's dy dx, and then we plug in. Okay, so you got to do the power rule. Drop the power, subtract 1. Drop the power. Oh, yeah, okay. Subtract 1. Put it back. Yes.
Is that a 1x?
Yeah, that's a 1x because 2/3 times 3/2 is 1. You don't really have to write the 1, but I wanted to make sure that you knew I wasn't just ignoring the coefficient. Okay, what has to move? Well, I have a negative exponent and a root, so both of those things have to change. Notice that the 1/2 is just gonna stay there. And the square root, okay, goes in the denominator. And then on the second part, it's just the root. The exponent's positive, and the variable is in the numerator. So we get plus square root of x. Okay. Step 3. dy dx when x equals 6. It just means plug in. That's all that means. Okay, 1 over 2 root 6 plus root 6. Okay, so what happens here, okay, you have to have common denominators, right? That's how you add things up. So right now, this is over 1. I need a common denominator. So the way that you do that is you take this denominator and you have to multiply that to the other fraction. Okay, so we get 1 over 2 root 6. So this first piece doesn't change. This one becomes 2 root 36, right? That's how we multiply those two things together. Over 2 root 6. Okay, because I had to do a common denominator. Okay, now I do notice that root 36 is actually 6, so I'm going to simplify that. So we get 1 over 2 root 6 plus 12 over 2 root 6. Now I can add them up. 13 over 2 root 6. Okay, when you have just integers and regular fractions, your calculator can do that perfectly fine. When you have radicals, your calculator is going to give you a decimal answer. I don't want a decimal answer. I want this kind of answer. Now, you can leave the radical in the denominator. That's fine. Okay, you don't, but in Delta Math, it does ask you to give a simplified fraction, which means it wants you to add them up. So if you don't have the common denominator, you're going to have to do the common denominator to add those two pieces together. Okay, so recap. First, you get the power format. Second, you actually do the derivative. Third, you actually plug in and combine your numbers. Okay, so we're going to look at higher derivative notation. Okay, we're not going to do any applications with these yet because first we have to learn the rules and then we can do some fun stuff with it. Okay, so here we go. F of x is the original. Okay, so the original is f of x. The first derivative is f prime of x. We're like, sounds good. We've been doing that for, a week or so now. Okay? But what if I want the second derivative? That's why it's called higher derivatives, where you keep going. So what that looks like is, see how there's 1 prime here? It's 2 primes. Means do the derivative twice, etc. Okay, so the third derivative, because one of those problem sets has a different notation when it's asking you to do something, and you see like these extra primes. Okay, so if I want the third derivative, 1, 2, 3, 3 primes, triple prime, means do the third derivative. Dot, dot, dot. Okay, so we don't really write more than 3 primes because it gets a little tedious, but you might see like a little parentheses and a 4 or a 5 or a 6 because it gets a little bit hard to continue writing that many primes. Okay, so that's a notation. It's asking you to find the first, second, third derivative where you do the power rule multiple times. Okay, so we have 2 notations. We have the function notation and we have the y notation. So if you're just given y equals, the first derivative is dx of y. Right? It means find the derivative of y. Well, that is dy dx. You're like, okay, that makes sense. Dy dx is slope. First derivative is slope. Yeah. Okay. Second derivative means find the derivative twice. Okay. d dx of y. It means do the derivative twice of y. So what this looks like, notice that you've got dd, which is d, I know, I'm going to say squared, but I'm not really squaring it. It's just, there's 2 of them. Okay? D squared with a y, okay? And dx squared. And it pains me not to write parentheses here, but you're not going to see parentheses written in any textbook. So it really kind of does mean that there's a little grouping here, okay? But you're not going to see textbooks write that parentheses. For some reason, they consider dx like one quantity, like actually, okay? So notice it's d squared y over dx squared. That means the second derivative because you're finding the derivative twice. Okay, the third derivative means, right, d dx is the directions that mean find the derivative. It wants you to find the derivative 3 times of the starting point. So that's d cubed y over dx cubed. And again, you're never going to see these parentheses in a textbook. And I'm just going to say dot, dot, dot. And we're just going to do one example. That's it. Find okay, so it's just the notation. Find d cubed y over dx cubed. That's it. That's what it wants me to do. Find the derivative 3 times. So we're going to start with y equals 4x cubed minus 3x to the negative 1 plus, let's do plus 12x to the 1/2. Okay, so notice that I kind of mixed it up with different types of exponents, right? We have positive, negative, and fraction. It's already in power format. And so this wants 3 derivatives. So 1, 2, 3. Triple prime. Now I decided to use triple prime because it was faster than writing the other notation. They're interchangeable. Okay, that means do the derivative 3 times. Okay, so here we go. So the first time I'm going to get 12x squared plus 3x to the negative 2, 6x to the minus 1/2. Okay, that's the first derivative. Then you just do it again. 24x minus 6x to the negative 3. Just be really careful with your pluses and minuses, right? Minus 3x minus 3 over 2. Okay, yep. And last time, go bright blue. Ooh, purple. I got purple.
Would you have to change the order?
No, you don't have to. It's actually in order because the exponents go from the biggest to the smallest. Except I guess these two, it doesn't matter. Okay, here we go. One more time. 24x to the 0, so that goes away, plus 18x to the negative 4, plus 9 over 2 x to the minus 5 over 2. That's it. You just do the power rule however many times it asks you to, in a row. Now, notice the directions. Notice how my problem started. Okay, start with negative fraction exponents. That means that you can end that way also. So you don't have to do any converting or rewriting this. You can just, that's it. That's your answer.
Is there a delta left on this?
There's one section on the 4.1. So I think there's what, 3 problems?
Yeah.
Yeah. Okay, that is it.